So I'm going to concentrate on tools to teach Faust. And we already seen some of them, and it was very interesting to see your workflow. So it's, I will probably skip this overview, mainly say that Faust is based on a purely functional approach, and we have already yesterday discussed about functional programming, and I think this is a very appropriate model for doing signal processing. After all, you can see signals are as a function on time, and signal processor are second-order functions on signals, and Faust is based on this block diagram algebra, which are third-order functions on block diagram, so to speak. So in Faust, everything is a signal processor, and we compose more advanced, more complex signal processor using an algebra of 5 composition operations, and we have seen in the example some of these operations. Here it's a very simple example of yesterday. You missed a nice concert also yesterday with the smartphones. And so for those who were at the concert yesterday, one of the applications was SF Windy, which is a wind simulator. And this is the code, the implementation of this wind simulator. So basically, you start with a white noise generator, expressed by this expression here. Then you create, you see the wind generator as a white noise filtered using the Moog filter that Julius presented, and you say that the more the speed of the wind is important, the more you are going to have higher frequency in the filter, and then you specify the speed using a slider. And here the interesting part is the way that you map the accelerometer of the phone to control the slider. And because we want a very smooth movement, the slider is very filtered. The movement of so it takes time to reach the change values. And finally, you have the process, which is basically you connect the movement to the wind simulator. Okay, so as you already know now, Faust is a compiled language, and the role of the Faust compiler is really to generate the most efficient implementation. Basically, in Faust, the way you code in Faust theoretically should not be important. The idea is that the people using Faust are not computer scientists. They just express the mathematics that they want, and the technology should do the right implementation for them. And Faust then is a high-level alternative to C to develop audio application, as we've seen, but also plugins in various formats. So you already seen the demonstration of this very interesting application. So I will skip that. There are several places where you can learn where Faust is used for teaching signal processing. Obviously, Stanford and Karma is the prominent place for that, but also at Albert Place. Edgar Bergdahl also now at Louisiana State University use Faust in combination with MaxMSP. Here, obviously, at Université de Saint-Etienne, we use also Faust, Laurent and myself. It is used also in Paris 8 by Alain Bonardi, who is teaching programming language, computer music programming languages. And there are some punctual, how do you say that in English? Punctual, okay. Courses in particular at IRCAM and other engineering schools. So, most of the programming languages that we use in computer music are interpreted languages, like Max, for example, PD, C-Sound, etc. And now, starting, I think Faust was the first one, there are now also compiled languages. So, by the way, don't miss the presentation of Kronos this afternoon, which is also a very interesting audio language which is compiled. There are other compiled languages like Heavy, which is a PD compiler, and obviously Gen, implemented in Max MSP. So the advantages of interpreted languages obviously are the easy to install. They are easy to install because they are self-contained. So basically you install Max and it's easy to install. A second advantage of interpreted languages is the fact that you are very fast to go from editing the code to running the code. Obviously, the disadvantages are a slower execution compared to a compiled language, slower execution that a very clever implementation in these languages can hide, so to speak. In particular, the fact that they implement all operation on vectors instead of samples. So it means that the cost of interpretation is diluted, so to speak, by using vectors. But this implies that in these languages you have a vector semantics. You cannot work on filters, one sample delays, etc. You have to all these filters have to be implemented as primitives in the language, and also because these are interpreted languages and systems, so to speak. Once you have your code in Max, it's in Max. It's not in PD. It's not in Super Collider, even if there are bridges between all the languages. But it's more difficult to deploy. So with the compiled language, you have fast execution. You have, and because the execution is fast, you have sample level semantics, which is very interesting, and also easy to deploy programs. You see in the talk of Julius that what is generated by the Faust compiler is basically a C++ class. You can just take this C++ class, it's completely self-contained. It doesn't require any dynamic memory allocation, doesn't depend on any DSP library, etc. So it's easy to reuse in a different context. But obviously the disadvantage are this edit, compile, run loop, which is quite long compared to what you can do for with an interpreted language. It's also more difficult to install. Because you need to install Faust, you need to install development tools, Xcode, for example, on the Mac. You need to install SDKs, for example. So there are many dependencies that make things more difficult, especially for musicians. Once everything is installed, so it's okay. But if you do a workshop, for example, then it's complex to use the tools, traditional tools. So what I'm going to show you is different tools that try to fix these disadvantages of a compiled language by simplifying the compilation workflow, by speeding up the edit, compile, run loop, by having easy to install self-contained tools, and even zero installed web-based tools. We already seen the online compiler. Okay, so basically these tools are divided in three categories: the command line tools, the embedded just-in-time compiler tools, and the web-based tools. So the command line tools, you have seen the Faust to Core Audio Qt or Jack Qt used in Julius' demo. But for example, if you use Faust to CA-Qt to create a core audio Qt application on the Mac. It takes, on my MacBook Air, it takes 13 seconds to compile, which is, when you are in the flow of developing things, it's a lot of time. So personally, I don't use directly the command lines for with the students, but I tend to use FaustWorks, which also use the command lines, but is interesting because it can show you how in real time the generation of the block diagram. So let me give you a short demo of FaustWorks. J'ai combien de temps? Je suis parti. C'était à -5.
Oui, oui.
Ok. Alors. Okay, let me open FaustWorks, and I would like to show this real-time block diagram generation and code generation. So this, I won't detail the code, but this is basically this describe how you can process incoming signals using an Hadamard matrix. And the description of this Hadamard matrix is made using pattern matching, which is a feature developed by Albert for the Faust compiler. So you have a nice recursive way to describe a circuit. And here we use this. So here we have an Hadamard matrix of size 2. But let's move to a size 4. And you see the block diagram is regenerated in real time, as well as the C++ code. So when you start working with Faust, it's a nice tool because you often want to see the block diagram to make sure that your code is correct. So the FaustWorks is nice for that. Let's make something 16. So you see the. So here you are happy not to wire manually, like in Max, all the connections. Let's make a big one. Okay, so you don't see anything because now it's okay. So this is I tend to use Faust, or recommend to use FaustWorks when you start to just have a quick view of what your textual code do, because you see the block diagram in real time. But it's the loop is still slow, so to speak. So no. So to try to accelerate this edit, run, compile, run loop, we developed several tools that embed the Faust compiler as a library, and we rely on the LLVM infrastructure to have a complete in-memory compiler. So you give basically a string that represents your Faust program, and you get a pointer to the implementation running code for your Faust program. So a very nice tool to do that is Faust Live. So Faust Live, let me show you a demo of Faust Live. Okay, so here we have two applications that are running in Faust Live, and they are connected using Jack. So let me start also. It's already started. Jack. Okay. So here we can see the connection between the two. Okay, so Faust Live 1 is this Kisana application and goes into Faust Live 2, which is the reverb, and the reverb is connected to the system. What's very nice with Faust Live is that while an application is running, you can just replace very smoothly the behavior of that application. For example, here we have a free verb, but I'm going to use a wah-wah pedal of Julius. So where it is? No. Okay, so let's. Okay, so now I'm going to take the wah-wah, and when I will drop the wah-wah, it will be compiled on the flight, and the two behaviors will have a time of cross-fading between the two behaviors. So this is very nice when you want to try something in a context. You can create your context, have all the modules, and work on one module. Edit as soon as you save the file, everything is recompiled and run. Another interesting thing with Faust Live is that you can do remote control of your application. For example, here I can. If you flash this QR code, for example, you will be able to remotely control this application, because Faust Live embeds a web server in order to control the application. You need to be on the same Wi-Fi, which is here at your home. I can simulate what happens if you open that. You see here a web page. That is the user interface, and I can control it. And you see here you have a drop your DSP code here. It means that in the classroom, for example, I can have my computer demonstrating something, but the students can also take their own code and drop it here, and it will be executed on my computer. You can do the same thing with OSC also, which is interesting if you want to control things. And another interesting aspect of Faust, because let me stop that. Obviously, here Faust Live is interesting because it's self-contained. It works on Linux, Mac, and Windows, but it's easy to install. But obviously, you just run the application. So so what is missing is the fact that you can use Faust to generate applications for other platforms. So for that, we have a special remote compilation service running on a machine at GRAME. So, and if you type command P, oh, okay, it's not running for some reason. Why that? Ah, maybe, okay, maybe I changed the configuration. Let me check if I have the right configuration. Okay, so it's not. So the address is http://faustservice.gram.fr. Save. And now, okay. So when you use this export manager, it connects to the service, asks for all the available targets, and allows you to compile for some target. For example, I can decide that I want to create a standalone application or maybe a pure data version of this program. So if I do export, it sends the code to so basically Faust Live here, it's just a front end for this remote compilation service. And now we have the export that we can save and use on, so here, for example. So it's a nice tool because you can have the just-in-time compiler, so it's fast to test things, etc., but still be able to export things. Okay, we have the same thing in Max MSP with FaustGen. So if you are a Max user, you can just install FaustGen, which is an external object for Max MSP, and edit your Faust code and run your Faust code. As soon as you save or close the window, then the code is recompiled. So it's also very convenient because you have all the power of Max and all the environment of Max to test your programs. This is more recent, is for Faust for processing. So you can, we have an embedded version of the Faust compiler for processing. Let me make a demo of that. Okay, so going to start processing. I open the examples, and here you have a set of examples. So I can open this ARP automation, for example. And you can see the code here. So you create a Faust processing object, and you give the code as a string. And then you can build the user interface on top of that. So basically, just generate the audio engine, and you can query this audio engine to know what are the name of the sliders and the range and values, etc., and build the user interface on top of that. And then when you run it, it creates a Jack application. And here it is. So it doesn't work. Why that? Because probably it's not connected with Jack. So here it's the So this is interesting because many students that don't know how to create an audio engine, but knows how to create a user interface, they can use this approach to build the user interface on top of that. Okay. Now. This is a very interesting. I have a video of that. How much time do I have?
25.
25 minutes?
Yeah.
Oh, great. I will run out of things to say. So let me run a little bit of the video of PMix. Because it's a very nice, it's used the Faust library, the embedded version of the Faust compiler, within a VST plugin. So it means that you can use it in any VST host. So PMix, and this is not developed by us, by Oliver Lacking in the UK. So here it's kind of live coding environment based on Faust within a VST plugin here running into Ableton Live. So it starts with a very simple effect. It's a gain control. So you see, as soon as the code is saved, it is recompiled, and now you have a stereo version of that. And you can, what's interesting compared to Faust Live or Faust Gen is that within this environment you can create several Faust applications that you combine. And you see also the block diagram in real time. Okay. Oops. Okay, so now we are moving to web-based tools. So you already have seen in Julius' demo the online compiler. Maybe what I'm going to show you on the online compiler is the fact that now you can. What's interesting now is the fact that by combining asm.js and the web audio API, you can run real-time audio application in the web. For example, here it's a simulation of the Yamaha YC20 organ, but it's in a web page. So if I start a MIDI keyboard, well, a fake MIDI keyboard here, and if I go to this web page, here the synthesizer, I can just connect to this web page, connect the keyboard, and start playing. So, okay, let's move that into the other page. Okay, so here. And it's a pretty accurate simulation of YC20. And it's described, it was implemented first as a VST plugin, so using Faust. But then once the asm.js backend was introduced, then it was very easy to just port it and recompile it to run on the web. And Laurent and Thomas have developed a very nice harpsichord for the web, which is also. So we foreseen that more and more of this synthesizer and audio effects will just run in the web, and it will be as easy as going to Gmail to read your mail than to go on web pages for that purpose. Okay, so the online compiler, maybe I can show you the yes, how you can. We recently had the fact that now we can compile for the web using the online compiler. So it makes it very, very easy just to run code from the online compiler. So here it's the online compiler, and I'm going to make a synthesizer, a small organ with the online compiler. So basically I can start with the sine wave here. This is the description of a sine wave generator. We can look at the block diagram. An interesting feature developed in a past project is the automatic documentation developed as a mean of preservation of the Faust code. So if you go to automatic doc, it's going to generate a PDF that is the exact mathematical description of what your Faust code is doing. So you see the PDF here. And then you can also execute the code. And here, instead of choosing Linux or OS X, I'm going to choose the web. And now I can choose audio. And I have a web page that I can run. Okay. So that's very convenient because you have nothing to install. You need to have, well, there is a lot of incompatibilities between the various web browser. Not all support MIDI, for example. But if you use Chrome, you are on the safe side, so to speak. And then I'm going to create an organ. It's based on the sine wave oscillator. If we look at the code, here it is. You see the timbre is generated by using 3 sine waves with coefficients for the harmonics. I go to the exec, and now instead of choosing audio, I'm going to choose polyphonic. And now we have an organ, and I can connect a keyboard and play it. Okay, so you see it's very easy to create a polyphonic organ, well, simple one, using this, tool. Okay. So we have seen the documentation generation. It's also, this tool is also very convenient to see the block diagram of a program. So I must say that Romain Michon, where are you, Romain? Okay, is developed most of this website and the online compiler. And also yesterday, if you were using an Android phone, he is also the developer of the Android architecture file for that. Okay, so the last thing I would like to show you is the Faust playground, which is really a prototype. We are working on that. But here the idea is, now that we are able to develop web pages that are synthesizer, audio effects, etc., using Faust, if we have a mean to just download the source code of all these effects and recombine them and recompile them and republish them, then we have a kind of very worldwide Lego box with all these effects. So this is the vision we try to push, and the Faust playground is a way to go into this direction. So let me create, and if you have your an Android phone, then you can take it and we are going to build an application for your Android phone, and you will be able to scan the QR code and download the application. Okay, so Faust gram.fr. So with the online compiler rely on a server for doing the compilation. Here we are completely on the client side. So you start, this is a version for the kids, so it's a little bit strange. I call my session Yann. Then so here I can take any URL containing Faust code. Here I have a catalog already done, but it's like if I was taking them from the web. So I'm going to take this one, for example. So as soon as I drop the URL, the code is compiled and it is run. And so everything is done in JavaScript. So we have a version of the Faust compiler in JavaScript, and with a backend that generate asm.js JavaScript, and that use the Web Audio API. Okay, so now I'm going to take a wah-wah effect. So with asm.js, the speed of the application is maybe just 2 or 3 times slower than native C++ code, which that makes it really usable. So I'm going to connect this like this. Okay, once I'm happy with this application, I can finalize ton application. I give a name, tune, and it is compiled on the web server. Now it's fast because it was already on the cache. Otherwise, it takes a while to generate the Android application. And if you scan the QR code, and you have the application running on your phone. Est-ce que je peux zoomer? Oui, je peux zoomer. So in principle, this is the position to stop the sound, or most application. Okay. Is it working for someone? No, Albert? No? Oh.
Am I on the right network?
No, you don't need, because here it's the address on GRAME's server.
It's basically
Okay.
with my QR.
Okay.
With the phone, you should throw it away.
Okay, so probably time to conclude. So what's missing? Well, documentation for the libraries. I think for the students, it's really they have currently to go into the source code of the libraries to discover all the interesting stuff that's inside, especially all the libraries developed by Julius. We still have also a big problem with error messages. It's complicated. Perfect, it's working. It's complicated in Faust to generate error messages, especially when the error arrives from the algorithmic part. When you are generating algorithmically a Faust circuit, and in that circuit you have an error, then there is no line where you can say the error is at this point. Like with templates in C++, it's you have huge error messages. What we are missing also are collaborative editing tools, and so it was very interesting to see in Jason's presentation about this idea of having collaborative tools and other presentation too. And also, what is missing and even has been removed from the current version of the online compiler is an easy way to do code sharing between the participants. So I think that it would be very nice to be able to see have a way to see how other people are using, I don't know, reverb, for example. You are typing reverb and you see how other people are creating and using reverbs. It would be very nice. In Max, for example, the help file is very well done, and it's very useful because then you can easily understand how to reuse something. We are really missing that for Faust. And obviously, as already mentioned, within the Fever project, we are working on the multi-rate and multi-dimension extension of Faust, which should be nice when it's done. Okay. So, thank you.
Okay, so we have time for questions.
Yeah, I think on the documentation for the libraries, it should be pretty easy just to write some kind of script that parse the libraries. Because so the thing is, I think Julius documented the libraries very well within the library, right?
Exactly.
So you could just look at the comments for each functions and create some kind of automatic system that would parse the library and then
yes,
and just generate some kind of automatic documentation based on that. So
actually, it's already done. There is. It's already done. Now we have to specify. I think that I did that for the mat.lib library, and Julius is currently doing that for your libraries, right? To reformat a little bit. So I was very inspired by the way Julius is documenting its own libraries. And we just add so that it's basically markdown format. So it's markdown with the comments, the slash of the comments. So we extract that and we generate a markdown file that we can then use in any way we want. But nevertheless, we need to have a tool to be able to read that documentation. There are still things to do for that. But this is exactly your idea, yes.
Okay, yeah.
I think that it's possible to compile in many other languages like Java, C++.
Yes.
But how do you plan to maintain this compiler when, for example, a new version of C++ arrives or a new version of Java is coming? Are there a lot of developers working for that? That's what I mean.
No, unfortunately not. Well, the maintenance problem is a real problem. Currently, it's more a problem for the various architecture files than for the code generation. To my knowledge, we never had so far problems with the generated code of not compiling anymore, or in C++, for example, because we have it's a very conservative C++ code, very simple and doesn't use any real extension. Here, C++ there is no templates, etc. And C++ is just used here as a way to pack everything together. Okay. But for the architecture file, yes, it's a problem. It's especially for the phones and iOS and Android. It's always changing, and you always have to do maintenance. And so we spend a lot of time doing maintenance.
One question would be how we have multiple online compilers. So because the Faust website has been a little bit unstable, or maybe it has been hacked by the NSA or something. So maybe we could distribute this stuff a bit more than it was.
So we started to have all the online compiler and the Faust website itself and the Faust playground as GitHub projects. So it's in principle it's quite easy to just even not fork it, but just copy on your machine and run it on your machine. Yes, you just need to have Apache running, and that's it, basically. And setting and do the right setting for Apache to. So in principle, yes, but it's it's a lot of work because we have this crash and it's not just that you have to keep the code, but you see, for example, all the PHP code was not running anymore on modern PHP. So.
Yeah, on that point, well, we already talked about that, but like Karma were telling you happen to post a version of the online compiler on the Karma server at Stanford, so that there is.
We will certainly do that, and also, for example, we were in China with Laurent for the last 2 weeks, and in China you cannot use anything which is Google related, and everything goes through firewall, and so just using the online compiler in France from China is possible, but it's slow. So we are probably going to have a machine there so that the Chinese market can be addressed properly.
All right.
Yes.
It's a really long question, so maybe if you have a short one.
Too long question.
Right. So two short questions maybe about the URL that where the Faust code is embedded is stored on the web. Is that a pointer? I could see some. Are there some URL that are pointer to code? Or I was thinking, is it possible, since the Faust code is really tiny most of the time, if it is zipped, it should maybe fit in 140 shells or something.
You mean to directly code the code into the URL?
Yeah, I don't know.
Yeah, that.
All this code, even for complex things, you have this encapsulation possibilities of calling a bypass immediately. The end code is really tiny most of the time. So if you zip it, it should be like this zip max format, which is maybe a detail, but made a big difference in the forum for sharing code. So this tiny format is very useful.
Yeah, probably. Currently, what we do is to have a kind of RESTful API for the server. You send the code to the server, and the server give you an SHA-1 key if the code is correct. And then from this key, you can ask for all the targets, all the available targets. And it's stored in a cache. So you have a kind of relative permanence of the code. But embedding directly that would be a possibility. And also it's probably very interesting to embed the Faust code inside a compiled object. To have a new method, give me the Faust code of my running program, and to be able to recompile things. This will also contribute to blurring the difference between interpreted language and compiled language. We made experiments of cross-running program from migrating running program from one machine to another with a different architecture, and using Faust and LLVM, it's possible to do that, and that's very interesting, because, for example, if you are developing for phones, it's very long to just compile things. But if you can, from Faust Live, just upload a running code into your telephone, then it's very quick to experiment with the code. So. Yeah.
Yes, I would like to raise a different kind of issue, a bit provocative, so please don't take it. It's actually to all the audience as well. I mean, I projected myself 40 years ago. I was a 15-year-old young child playing just piano, classical piano, and studying harmony at the conservatory, and had courses of Peppino Di Giugno and Pierre Boulez explaining what later became the 4x and traitement, and John Chowning explaining his ideas about Turenas and then Fonet and then Stria and then Fonet, and or Risset talking about his own songs and so on. What led me into computer music was not, in a totally passionate way, was not the quality of the ideas that they were proposing, but the aesthetic shock that I had when listening to what they were doing, onto the ideas that were exposing, but from an aesthetical point of view. Stockhausen talking about composing sounds rather than composing with sounds, for me was just wonderful, but I can compose sounds, new form, new things, contact, the momentum form, and so on. Now I project myself 15 years old here, at this seminar. And if I want to become a techno freak, I think it's great, because the technology is just wonderful. I mean, it's fast, it's real time, you hear everything, it's over the world. Faust is totally impressive from this point of view. However, if I would react as a musician, and then please forgive me, I don't talk about you or Julius Smith, I talk more generally, it's a question I ask myself. The example is so shit for me, but I would never, ever want to go into electronic music when I hear the things that you or the others, or people, also at IRCA, are showing. So what is missing for me is, again, the aesthetic shock. I have a technological shock, because it is great. At that time, there were, 40 years ago, there were no demonstrations possible. Just a piece and some ideas, maybe some utopias, but just, now it's everything impossible. But, what I see is just entertaining, cheap, semitonal based, minimal music with minimal thinking. So my, greatly interactive, but I don't care, but I want aesthetics. I'm a musician, I'm not a techno freak. I don't want to become that. So my question to myself is, did I miss the turn of the century, so I'm just old and reasoning like an old composer? And this came, wow, great, the new generation is doing like this. Or why are you, with all the knowledge that you have, and all the power of development that you have, and really, Faust is great, why aren't you be able to make something more than just a cheap electric guitar for me? Because sorry, but a Fender for me sounds better than what you did. That's for me, what is missing is, why are the examples so cheap musically?
Well, I'm not sure that I agree, but anyway, if you have to, it's very difficult to demonstrate a programming language, and you need somehow to create simple things, and maybe there is a way to make very musically interesting simple things. But here, since the point is more to show how you express things in Faust, for example, well, the organ is made from 3 sine waves. Okay, it's a very cheap organ, I completely agree with that, but the advantage is to see how simple these simple things can be expressed. So there is no musical pretension on all these examples. There are more a pedagogical pretension of how you program with Faust. Now, for me, the example of Julius I like them very much. So it's maybe a question of taste also, even if it's more entertainment music or.
Yeah, if I may add something to that. So to me, well, at least, and you might not fully agree with what I'm going to say too, but but I think to me, Faust is, you can't really compare Faust to Maximus P, Super Collider, or like, it's lower level than that. So for me, Faust has always been a tool to make tools, basically. And so very often the way I use Faust, and very often the way I see people using Faust, is to make an object for Maximus P, or for other programming languages because it's lower level than all those programming languages. So I think the musical part is very oftenly done maybe in something else than Faust directly. So I don't know if that's a good answer to your question, but
we are not businessmen interested in capital venture in Faust. We are qualified people of a certain knowledge in a university, so in another audience. But I mean, the remark I made just now, I would make the same for many of the demonstrations of the IRCAM forum. So it's not a problem of you or Julius. I just want to raise this as a more general issue because I see this danger with many of the view things. So it has nothing really, absolutely nothing personal. Plus, I think, as you said, Faust is a great language, lower level. It's used also in open music now, so it's controlled by open music. So it's really, I'm not at all on the contrary. But as I say, you are talking to qualified people. Why not doing, if you want to have, so we don't need this kind of cheap demonstration. We know that, so we're not going to buy it for it. We're going to see, and I actually don't even want to know how simple it is. I would like to know to have how you make a complex example, because I know how to make it simple. It's the same as in C sound. It's really C-Salon and C-C was almost the same as Faust, to a certain point of view, not technologically. But you draw, you connect two sides. So why not, for example, I don't know, you make a sound from Contacte. There is always the patches in Stockhausen's Aufführungspartitur, or a sound from Songe. I mean, just to give an historical example, because you mentioned that. There is, and it's the same problem that I also found in Max. You have great demonstrations, then you want to do something complex, and the patch explodes because you just raise the order of complexity by a factor of 2, 100, 100 times more. So that's what for me is a bit strange. I mean, I would like to see how you do complex things in Faust, how you cope with that, not just a simple thing like this.
Yann spoke about China, but in China we have done some concerts only played by Faust, and it was Durenas played live with only Faust. You speak about some
complex example.
Yeah, that would have been a nice example to see rather than an electric guitar, for me at least.
Yes, but we did that 2 weeks ago in 2 times in China. But you see, how to say, if you want to make a musically interesting example and a easy to understand example, it's twice more complex than, you see, the point. And somehow the concerts are the way to see in a musical context Faust in action, so to speak.
Yeah, but it would be interesting how the Faust conceptor, for example, the Faust creator, explains a complex patch. A simple patch, I don't need you to explain 3 sine tones. I mean, I can ask other people. But I want to see how you, or Laurent, or somebody, somebody who really went into complex project with Faust, how they tackle that in a demonstration. To see how, for this kind of audience, of course, I don't mean for children or for a demonstration within a 20-minute or 15-minute moment where you just have to do your business. And for me, this was a bit missing. Also in Julius Smith's presentation was missing. Okay, he had the historical approach of this MOOC filter, so fine. But I mean, before hearing how a low-pass filter, which I have heard for years, I say, okay, I know you can do it, but how would you do something more complex? But again, it's a question that I ask myself, because I see it also in some of my younger students, sometimes I'm puzzled by what they consider as interesting examples. I really don't know what to tell them, because you download a song from YouTube, MP3 is already greater quality compared to the sound you download. You analyze it with a free software that is just gives you any kind of things. You make that and you say that's good music. Maybe, but I'm a bit puzzled by that myself. The question is for you, but also for me as well.
Yeah, I understand. Yes, it's a legitimate question.
Yeah. So hearing you describe that, I'm thinking the same thing about a lot of the, say, like vocal music examples that we saw yesterday, where you go through a simple example, you end up with a bunch of chords being played back on the grand piano sound on the built-in MIDI synthesizer, and it's a big leap to get from there to a full piece of music. And I think that it's it's something I struggle a lot with when I'm teaching, introductory graduate students, is I want to show very simple examples so that they don't get overwhelmed at first, but then I also want to come from the other direction and take real pieces of music and break them down for them. But there's often this leap they have to get across in the middle to get from the building blocks up to the real examples and get there in their own compositional practice. I think that's where one of the biggest challenges for me as a teacher is how to bridge that, because I can kind of come up building things organically so far, and then I can come down trying to break down real examples for them. But there's always something in the middle. And another thing that ties into that is I think that we as a community for decades have not been as good as we should be about composers sharing our methods and our code with each other and making that open in a way that's easy for people to access. There's great examples like talking yesterday of reproducing historical examples, the repertoire project, and all these kinds of things to try to get into how seminal pieces of work have been created. But if you go to a conference and you see a performance, it's very rare to actually get access to that code and to be able to dig into it or to take it to your class and take it back with you. And often, even if you do get that code, it's illegible, and it's a mess no matter what it was created. It's just it's not something that you can really break down or that you want to be like the model of how to do things for your students. So I think we have a lot of work as a community to try to coalesce that. I mean, I remember reading articles in CMJ 20 years ago that were saying we desperately need to do this, and that hasn't changed. So I'll reiterate that.
No, but Faust is like Cézanne or Max. You can do everything you want. So we don't need to explain how to create good sound with Faust. It's the same thing that in Cézanne or everything else. So there are a lot of concerts. I spoke about Turinas, but there are concerts in GRAME and everywhere. You can do everything you want with Faust. What is interesting is the way we can preserve, the way we can distribute things. That's why we are talking about that now.
Yeah, but why don't you do it then? Why do you give us these examples? Do it.
But
I suppose for 40 years you can do everything you want, from music 5 to Cézanne to Max. But I mean, I from the person who made Faust, which is a great opportunity for me to see Yann talk about Faust. I mean, it's great. He has an insight on the instrument and on the software that I would never have. I would expect to see, okay, if you have a couple of demonstrations, fine, but then a real full-blown example, and then do it, show something that you said. But I find it's with his insight, not just from a sort of analysis, but with they show this picture, they show this. I understand sometimes it's maybe too difficult, but for me an analysis of that would have been very interesting and certainly very, very, very inspiring. Rather than, because I say, as musicians, we are subjugated by aesthetic shocks, not by demonstrations of electronic power. No matter, or syntactic elegance, no matter how good that is. So that's for me, that's the point for, and this is for me very clear when I teach. Sometimes I tend to insist on the elegance of a certain expression of a problem, which is for sure, for many of you who are great scientists, it's a very important point. But for a musician, in the end, it's how can I do something that allows me to express what I want in a way that is said like this is a bit simple, but it's actually much more complex because you can never really express what you want, and then you never know what you want to express, and so on. But for me, I would say maybe, especially on a longer amount of time in front of qualified audience, take once a time to get into, from top down, into a complex example and see how this gets into Faust and shows this possibility of the language. As you would analyze a complex patch from, I don't know, we say catalog of instruments.
But it's different, Marco, because in Faust, and it's different because in Faust, you're not going to, it's not a composition tool at all. So you're not going to use Faust to make a whole piece. You are going to use, for example, Max and use building blocks in Faust with other, combined with others. So it's a lower level tool. And what we want to, the point here of the demonstration is to show you that even if you are not a C programmer, if you are not, but you have musical ideas or signal processing ideas, then you can express them quite easily. So that was the point. And then when you want to demonstrate how you build from simple to complex, if you give directly a very complex example, then how do you can't, it's not possible to understand how things work. So here the idea was to make it clearly understandable, at least.
To retake the example of Turenas that Laurent just gave, Turenas was, well, the objects were implemented in Faust, but the overall implementation of the piece is actually done in Maximus P. So I think that's just a very good example of use that Faust was used in that case to create the lower level parts of the piece. You know, but then to put things together, you still use a software like Maximus P. So.
What would be interesting for me to see the part of Max, the part of Faust, maybe with more accent on Faust, just to see how the two interact, for example. Because I know this part we talked about Laurent, that for me it's an interesting thing that I want to see from inside, not only from videos. And because I think it's a great idea. So that's for me it's just, I remember I went into electronic music because I was...
I understand, yes.
And I say, if I see today, that even at the European Forum, I mean, which I heard for several years, not so interested. And to a certain extent, what Isabelle Nem showed yesterday with the minute electroacoustic was much more convincing aesthetically, because at least you have children, I mean, a young teenager doing something that was musically meaningful, conceptually clear, because how it sounds. And I found it really very much.
But you agree that we are not showing the same thing?
Of course, that's what I say. But I would say, you see how sometimes there is a danger, but I think in all institutions that deal with the technology, to highlight the power of the technology and the possibilities, and to downsize the value of the examples that show the technology, because these are those that eventually will seduce many of the musicians that would be maybe want to then study and invest time and energy into learning programming.
Okay, excuse me. We had a 30 minutes break normally. We have shortened it by 20 minutes. I think it's really an interesting debate. I wouldn't care if we don't have the break myself. I don't know what you think. There's another question. Do you want to keep talking about that? Or do you want to talk during the break? What do you want to do? I think
we can probably talk.
So I'd just like to add something to what Jan said and maybe what Roman said also, that in addition to composition, there's also interest in instrument building, effects design, and I think to improve the state of art there, we need to involve musicians and creative people with good musical ears in that discipline. And so the application of Faust and projects like, for example, my own, tend to focus on things that are more like instrument building than building compositions. And in order to enable musicians to do that, we need to teach them, we need to show how signal processing is done. And to accomplish that, I want to quote my colleague from yesterday's presentation, who had this wonderful sentence that elegance is not optional. Like, we need to improve the methods of programming in order to improve the state of art in musicians designing signal processors.
Okay, thank you. I think we're going to stop here and we can discuss further. Thank you.